Hello everyone, welcome back to our channel Imaginary Engineering. This is Kirti. In this video, we are going to build simple chatbot application using the Langchain, Streamlit and Groq API. Even if you don't know anything about a Langchain, Streamlit, you can still continue this tutorial. I will explain everything in detail. But only prerequisite is you should know the basic Python because it's required not in deep but at least you know the basic Python, that is fine. So let me give the brief introduction about a Langchain. What is the Langchain? So Langchain is the open source framework to build a LLM application. It is the most popular framework nowadays that help you to build a GenAI application. It is available in a Python and JavaScript. Then Streamlit is using the Streamlit you can build a UI interface, and using this Streamlit with the only few lines of code you can build your beautiful UI. So it's very useful library. We will see this in this video. Then Groq is a cloud platform that help you to call the LLM in cloud that hosted by many LLM models. We will see later in this video. So before we start, I will explain the architecture. So let's see the architecture. So here you see the PDF source file. We uploaded the PDF and then break it into the multiple chunks and generate the embeddings. Then we store that embedding in vector store. Then user enter the query, do the semantic search, find out the similar embeddings from the vector store, pass it to the LLM and generate a result. So this is the basic architecture. I will explain in depth. So the source, first we upload a PDF, and then PDF can be 10 pages, 100 pages, 1000 pages. It can be a small or it can be a large. So to process that PDF, we break it into the multiple chunks. So here we get the different chunks, multiple chunks. Then embeddings, what is the embedding is nothing but the text representation is a numerical form. As we know, our machine only understand the numbers, not a text, right? Only binary numbers 0 1, so it's required to convert our text into the numbers. So this embedding is nothing but the numerical representation of your text. So for each chunk we generate embeddings, and to generate embeddings you can use the anything. There are multiple options. You can use the OpenAI Hugging Face embedding. So in this video I am using the Hugging Face embedding. Then comes vector store. Now we generated embedding. We have the lot of embeddings to where to store that embeddings. For that we have the database. This is the vector store database. Then this vector store database is do the fast searching and provide an optimized way to store the data. If you use any traditional database instead of the vector store, suppose MySQL database, it's very hard to store all this embedding in database and then search that embedding from that database. So in vector store do the fast search and provide an optimized way to store the data. So there are multiple vector store you can use. There are you can use any vector store, Pinecone, Chroma, Face. I'm in this video I'm going to use the Face developed by the Facebook. So I'm using that vector store. Then user enter the query. Query is also in a text, right? So we need to generate embedding for the query also. And then we do the semantic search. We find the matching embeddings in vector store. And then once we get that matching embedding, we pass it to the LLM. Then LLM generate a result, and then that response we return back to user. So this is the architecture. I hope you understand this. And then I will show you the application. So I will upload the file. I'm uploading this GenAI documentation. If I show you, this is the GenAI. documentation, GenAI guide. Here is the topics, understanding GenAI, then case studies, future trend and opportunities. Basically, it shows the GenAI use cases and all. It's a small PDF, 10 pages only. So let's go back to our application. Enter your query. Let's say GenAI application examples. Enter. Here you see it's running. It takes some time. And now here we get our answer. It's returned with 15 examples: virtual assistant, content generation, chatbot, image and video generation, healthcare, education. Okay, okay, so this is the application we are going to build. So let's start our actual coding part. Folder is empty, there is nothing. I will open the new terminal and then we will create a virtual environment. So for that command is python -yum env virtual. This is our virtual environment name. The second one is our virtual environment name, and then we'll activate our virtual environment. Scripts slash activate, and here if you are using the Linux, then command is source bin activate. Enter. Now here you see this is our virtual environment. So why we are using this virtual environment? So suppose in multiple we have the multiple project, and each project we are using the different versions. So to keep all the dependencies separate out from each other, so you can create our virtual environment. So first let me install all the libraries that we required for this project in pip install. First I will install the Langchain, then PyPDF to read the PDF document, PyPDF, then install the face request role, and then Streamlit to build our UI interface and enter. It will take some time to install all the libraries. And then I will create a new file, chatbot.py, enter. Now first we will start with building UI. So let's import the Streamlit. Import Streamlit as est. Then we'll set the header est.header and we'll pass our string. Let's say my est.header and we'll pass our string. Let's say my first chatbot. Then let's upload the file. So I will write st.sidebar. This provider Streamlit also provide a sidebar. So sidebar. Then set the title st.title. Title I will pass the your Document, then document spelling mistake, document, yes, and then we want to upload the file. So this Streamlit provide the file uploader. To upload files, we'll pass the string, upload your PDF, and then we'll pass the type is PDF. Once we upload this PDF, we want to store it one variable. So let's call it file. And now let me run this Streamlit application. This is our chatbot. I will copy the path and say Streamlit. To run the application, command is Streamlit run, and I will paste the path here. So Streamlit run. Here our application is running on 8501. Here you see the nice sidebar. This is the header we set, if you remember. Here in code, here we set this header. My first chatbot, then sidebar, title, and file uploader option. Here we have the file uploader. Drag and drop your file. I'm selecting the PDF, and you can upload the PDF here. With the few lines of code, you don't need to write any HTML, CSS, only just few lines of code. You can see you build our UI very easily. And so next is after uploading, first we upload the PDF, and then after uploading, we want to shift. So next task is extract the text from PDF. Extract the text. First here we upload PDF. Upload the PDF. That is done. The next is extract the text. To extract the text, we are using the PyPDF to read the our PDF. So let's import that. We already installed, right? So PyPDF to import from PyPDF import PDF reader. Then PDF reader we have imported. Then first we check if file is not none. If file is not none, then we will read the PDF. We have the PDF reader. We pass the file, and then it will return the all the pages, all the PDF pages it will return. So here we get PDF pages, and then we will iterate over each page and then extract the text. So I'm using the for loop. So first I will declare one variable so we can print all the text, and then for loop page PDF pages have the method page, and then this page have the method extract text. It will extract the text, and then I will append it to this variable text. And now what I will do, I will write it into the our Streamlit so we can see the output text. Okay, so nothing here. What we did, we just extract the text from with the help of PDF reader. So let's go back to our application here, and I'm going to refresh the page, upload the PDF here. As I uploaded here, you see all the text. It extract all the text from our PDF. Let me run this application on my Edge browser, not here, and copy paste URL, enter. This is the PDF. Okay, this is the PDF. Same PDF that I have shown you earlier. This is the same PDF GenAI application. Let me close that process. So let's go back to our VS Code. Now next step, once we extract, first we upload, then we extract, and then we break it into the chunks. So next task is break it into chunks. Break it into chunks. So for that Langchain, I'm using the Langchain. Langchain provide the recursive character splitter. So I'm using that recursive character text splitter. So let's import first from Langchain text splitter. Import recursive character text splitter. So this is the recursive character text splitter I'm using. Recursive characters text splitter. It will take some parameter separators. The separator, that means that in which basis you want to break, you want to break your PDF, in which basis it can be anything. It can be the new line, it can be the white space, it can be the any special character. Depending on your use cases, you can change the separator value. I'm passing the slash n. Then next is chunk size. Chunk size, here I'm passing the chunk size 1000. You can pass anything. It can be the 200, 500, depending on your use case. Again, you pass this. Then chunk overlap. This chunk overlap is very important parameter. I will explain you. So here I am passing this 150. So chunk overlap that help you to maintain the contacts, maintain your relationship within the chunks. So what happen? Supposing it take words from the previous, it's take a character from your previous chunks to maintain the context and maintain that relationship between these chunks. Suppose you have the chunks, you break it into the multiple chunks in your PDF, you break it into the multiple chunks. There might be the case that breaks and context may be not maintained. You need some character from the previous text. So this chunk overlap, what it do, it takes the 150 character from the previous chunks to maintain that context. So this is very important. Then next parameter is the length function. And here I will pass the length. Then recursive text splitter will store this result in variable. So let's say text splitter equal to, will store the result in this text splitter. And after that, this text splitter has the method. This text splitter has the method split text. We will pass our text here. That text we have extracted from this PDF, we will pass here, and then we will store it into the variable. Let's say we store it into the variable chunks. I will write it into Streamlit, so you will get idea. I will first show you these chunks that we have generated. I will comment out this previous text. Let's go back to our application. Streamlit, refresh, open browser here. Select this PDF. It is running. Here you see it is running. And here we go. Here we get the multiple chunks. Here you see array of chunks. Here we get chunk size. I have given the 1000. Again, depending on your use cases, you change the value. So, and that chunk overlap, how that chunk overlap, if you see here are different chunks, the multiple chunks, and then the chunk overlap value I have passed 150. So it takes the 150 character from the previous chunks to maintain the context. So let's go back to the VS Code. Now chunks also done. Now next is to generate a embedding. So next task is generate embeddings. So to generate embedding, I'm using the Hugging Face embedding. You can use the OpenAI embedding also, anything you want. Let's go back to this documentation, Langchain documentation. First, you can go through this documentation. Langchain provide very nice, well-maintained documentation. So here is the Hugging Face embedding. And they have mentioned to use this you should have the sentence transformer Python package installed. So let's install this package first so we can use this. Let me open the new terminal. um, Go back to this, activate the script, then we go into our virtual environment and then say pip install sentence transformer. Let's go back to our documentation. Here I'm copying this Langchain interface import control P. Then next I will copy this code, going back to our VS Code, and simply go and paste it here. Mm, okay, now it looks good. This is the model name and this model argument we don't need actually, so I'm just removing that. I'm only so now we have installed the sentence transformer, but still we are getting this warning. So what I will do, I will install the Langchain community. And I will import this Hugging Face embedding from the Langchain community, Langchain community dot embeddings, and then we import this Hugging Face. Now that warning is gone. Yes, now we generate the embedding. Embedding is also done. So next is vector store. To store that embedding, we need the database, and we are using the face, which is developed by the Facebook. So let's import the face vector store first. So from LinkedIn community dot vector store import face. If I show you the documentation here, this first we have to install this. We already installed this Langchain community and face CPU, so we can directly use this code. So I will go back to our application, and our next step is create vector store. We have the face we have installed, so use that face dot. Here we have the method from text, and then we will pass inside this method from text. We will pass the chunks. We'll pass the chunks and embeddings. The embeddings that we have generated. So embeddings here we pass the lectures here. Let me rename this lecture. Uh, let's say instead of embeddings, so I will change. So here this phase has the method that from text it will take up two things, the chunks that we have generated and the embeddings. That means in the vector store it will store the chunk from suppose chunk A, and chunk A embedding is A0, then sorry, chunk embedding is A0, and then chunk B, then chunk embedding for this B0. Some similar to that, it will store the embedding for all the chunks. Then I will store this in variable. Let's say vector store equal to, yes, now we have our vector store. So now our next task is still now what we have done. First we upload the PDF, then extract the text using this PDF reader, read the file, extract the text, then break it into the chunks. We break that PDF into the multiple chunks, then generate the embedding, then create the vectors for using the face. Now we get a input from the user. So for that, our next task is shift get the user query, get user query. I'm using the Streamlit. So Streamlit has the text input. Yes, Streamlit has the text input. So we'll say enter your query. Enter your query, and then we will store that query in variable. So let's say user query. Then we'll check if that user query is exist. If user query If user queries exist, then we'll do the semantic search. So we already have the vector store created and it has the method similarity search. We'll call this similarity search method and pass our user query. So what it does, so this will take this user query and then do the similarity search, find the matching embedding and return this matching embedding. Here it will return this matching embedding, and after we get that, then we will pass it to the LLM. Now to make the LLM call, I'm using the Groq. So let's go to this Groq cloud. Here I have already logged in. If we are using this first time, it's very easy to just go and sign up using your email ID. And once you sign up, you land up here, this playground dashboard you see. So here dashboard playground, and here you can see this provide a multiple models. As you can see here, you can explore the more on this. Here you see the multiple models they have provided API keys. So let's create the new API key. Click on this create API key and display name enter, let's say chatbot, submit. Here is our API key, and copy this and don't use my API key because I'm going to delete that after I record this video. So to access the variable environment variable, let's import the OS, and after that os.env, and we'll pass the our Groq API key, Groq API key, and here is our API key. So now we get our Groq API key. Let's go to the Langchain document and see how we can use the Groq chart here. Here is the chart Groq, and first let us install the Langchain Groq and set the environment variable. This we have already set this environment variable. Now this is remaining. First we have to install this Langchain Groq to use the Groq in our application. So let's install this Langchain Groq. Now please let me copy this Langchain Groq, copy and paste it here. Enter. Yes. Now let's go back to the documentation. What they say. Okay, first let's import this Langchain Groq, chart Groq. Okay, let's import this. Let me copy it again. Import this chart Groq, and then this will call this chart Groq. Copy. Go here. I'm going to paste it. Model name. Here I'm passing the template. 1 second. I will remove these other parameters. Here I'm using the model Llama 3.18 billion instant. You can use the any other model also. If you go back to this playground, here you see they provide multiple models, many models. You can use the any model. You can use this Llama 70 billion 8192. You can use this model also. So let's go back to our VS Code. Then I pass the parameter temperature. This basically temperature define how creative you want your model to be. If you want, you can give the higher number also. Here I have given the 0, but you can give the higher number. If you give the higher value, that means you want more randomness in your response. If you don't want any randomness in your response, just give the lower value. Like I have given the 0. Here you can give the any higher value, 0, 0.7812, like this. And then maximum retrials I have given the 2. So this is the chart block, and it return the LLM, store it in the variable LLM. Now, next is we will have the we are using the load QA chain. Basically, this load QA chain let's for the question answering. Langchain for this load QA chain. It's very helpful for the question answering. So Langchain community. Let's import first, not Langchain community. Langchain chains. Actually, sorry. Langchain chains. Question answering. Import load query chain. This is specially designed for the question answer. Let's use that load query chain, and then we will pass our inside that load query chain. We will pass our LLM, and then chain type. Chain type, here I am passing this stop. You don't need to bother about this chain type stop. You just think like that you are passing entire your document to the LLM process. It's like a stop your things in bucket. So this load chain, and then we will store it in variable called chain. So chain is basically lengthen chain, that sequence of the steps, like we upload the file, we get the query, then we get the query, then we pass it to the LLM. Like this is a sequence of steps that happen. So next we'll run this chain, and then parameter we will pass the input documents. Input documents, here I'm passing the match, that return by semantic search. Here it return matching embedding, so match, and then we'll pass our user query. So let's pass the user query also. Question user query. And this chain return the response. So let's store the response in variable called response. Let's store it in variable. And next, what we'll do, we will show this response on UI also. I'm adding the subheader here, say answer, and then we will just write a response that we get. So we'll write response. So here our code is done. First I will explain. First I will let's see, go back to the browser, and then I will explain. So let's go back here and refresh the page. Let's upload the PDF. Here I'm uploading the PDF Gen AI guidelines, and here you can see it's running. It's extracting the text from the PDF, then break it into the chunks, generating the embeddings. It takes some time. Mm. Now here is our input field. Enter the query. Let's say tell in me use cases Gen AI applications. Enter. Here you see it's running. And here we go. It returned the answer. Here you see the retail, manufacturing, customer service. In PDF, if I show you the use cases, yes, here use cases, manufacturing, retail. This is the same use cases they have written, right? You get the same use cases that in that PDF that we have shown. So, let me go back to our VS Code and I will explain you code in. Let's see. Let recap what we have done till now. So first we start with the UI interface. We are using the Streamlit for the UI interface. Then this IPDF to read the document, read our PDF file, then text splitter to split the text. I'm using this recursive character text splitter. Then for the embedding is nothing but the numerical representation of our text. So I'm using this Hugging Face embedding. You can use the any embedding. For embedding, you can use the any OpenAI model or any other things. Here I'm using the Hugging Face embedding. Now then is a vector store. To vector store here I'm using the face. You can use the any other vector store. Then LLM model, I'm using the Groq. You can use the any model, OpenAI model or any other model. So this is the chart block we import from this Langchain, and this load query chain. This is specifically for design for the question answering. Then here is the API key. Here we get the Groq API key. Then first we upload the PDF. Then we extract the text. Using this PDF reader, we extract the text, iterate over each page, append the text. Then next is break it into the chunks. Then we use this recursive character splitter. These are the parameter we pass. You can change this parameter as per your use case. Then here we generate a chunks. Then we generate embeddings. I'm using this Hugging Face embedding model. So this is the model I have used for writing the embeddings. Then the vector store. This is the face vector store. It takes the two things, chunks and embedding. So it generates the embedding for the these chunks that we have passed. Then after creating the vector store, next is the user query. Enter the user query, get the user query from the user, and then do the similarity search. We will find the matching embeddings. We pass the user query. Then we'll call the LLM. Here we call the chat block. Then I'm passing the model llama 3.18 billion instant. You can pass the any other model. Then we set the temperature 0, and then here this load QA chain I have used pass. It takes the two things, LLM and chain type, and return the chain. Chain is basically that Langchain chain that create the query. It's then generate the embeddings and then pass it to the LLM to generate a response. So here is the we run this chain. We pass the our matching and then user query. So compare that matching with user query and generate the response, and then we just show that response on the UI. So this is the simple chatbot application we have built using the Langchain, then Streamlit and Groq API. I hope you like this video and you learned something new. If you did, then don't forget to like, share and subscribe to Imaginary Engineering. Thank you for watching.